Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
One of your primary business objectives is being able to trust the data stored in your application. You want to log all changes to the application data. How can you design your logging system to verify authenticity of your logs? The options are: Option A, write the log concurrently in the cloud and on-premises. Option B, use a SQL database and limit who can modify the log table. Option C, digitally sign each timestamp and log entry and store the signature. Option D, create a JSON dump of each log entry and store it in Google Cloud Storage.
To arrive at the correct answer, we focus on the keywords: trust the data stored in your application, verify authenticity of your logs.
The correct answer is option C, digitally sign each timestamp and log entry and store the signature.
Why is this correct? C. Digitally signing each log entry and timestamp creates cryptographic proof of authenticity and integrity, ensuring logs cannot be modified or forged without detection. Why are the others incorrect? A. Writing logs concurrently to cloud and on-premises provides storage redundancy but does not provide cryptographic mechanisms to verify or guarantee log authenticity. B. Limiting access permissions on a SQL database restricts user access but fails to offer cryptographic proof of authenticity or detect unauthorized tampering. D. Saving JSON dumps in Google Cloud Storage facilitates log archiving but does not include cryptographic signatures required to verify origin or authenticity.
Your company has a Google Workspace account and Google Cloud organization. Some developers in the company have created Google Cloud projects outside of the Google Cloud organization. You want to create an organization structure that allows developers to create projects, but prevents them from modifying production projects. You want to manage policies for all projects centrally and be able to set more restrictive policies for production projects. You want to minimize disruption to users and developers when business needs change in the future. You want to follow Google recommended practices. Now, should you design the organization structure? The options are: Option A, 1. Create a second Google Workspace account and organization. 2. Grant all developers the project creator IAM role on the new organization. 3. Move the developer projects into the new organization. 4. Set the policies for all projects on both organizations. 5. Additionally, set the production policies on the original organization. Option B, 1. Create a folder under the organization resource named Production. 2. Grant all developers the project creator IAM role on the new organization. 3. Move the developer projects into the new organization. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the production folder. And the remaining options are: Option C, 1. Create folders under the organization resource named Development and Production. 2. Grant all developers the project creator IAM role on the development folder. 3. Move the developer projects into the development folder. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the production folder. Option D, 1. Designate the organization for production projects only. 2. Ensure that developers do not have the project creator IAM role on the organization. 3. Create development projects outside of the organization using the developer Google Workspace accounts. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the individual production projects.
To arrive at the correct answer, we focus on the keywords: Google Cloud Organization, prevents them from modifying production projects, manage policies for all projects centrally, Google recommended practices.
Review the options on screen. The correct answer is option C, 1. Create folders under the organization resource named Development and Production. 2. Grant all developers the project creator IAM role on the development folder. 3. Move the developer projects into the development folder. 4. Set the policies for all projects on the organization. 5. Additionally, set the production policies on the production folder.
Why is this correct? C. Creating separate development and production folders enables central policy inheritance at the organization level while scoping the project creator role strictly to the development folder, allowing developers to create development projects without access to modify production projects. Why are the others incorrect? A. Creating a second Google Workspace account in organization fragments policy management, increases operational overhead, and violates Google recommended practices for central governance. B. Granting the project creator IAM role at the organization level permits developers to create projects anywhere in the organization, failing to prevent unauthorized creation or modification of production projects. D. Keeping development projects outside the Google Cloud organization prevents central management of policies across all projects and violates recommended resource hierarchy practices.
Your company has an application running on Compute Engine that allows users to play their favorite music. There are a fixed number of instances. Files are stored in cloud storage, and data is streamed directly to users. Users are reporting that they sometimes need to attempt to play popular songs multiple times before they are successful. You need to improve the performance of the application. What should you do? The options are Option A, 1. Mount the cloud storage bucket using Xfuse on all backend Compute Engine instances. 2. Serve music files directly from the backend Compute Engine instance. Option B, 1. Create a cloud file store NFS volume and attach it to the backend Compute Engine instances. 2. Download popular songs in Cloud File Store. 3. Serve music files directly from the backend Compute Engine instance. Option C, 1. Copy popular songs into Cloud SQL as a blob. 2. Update application code to retrieve data from Cloud SQL when cloud storage is overloaded. Option D, 1. Create a managed instance group with Compute Engine instances. 2. Create a global load balancer and configure it with 2 backends, Managed Instance Group Cloud Storage Bucket 3. Enable Cloud CDN on the bucket backend.
To arrive at the correct answer, we focus on the keywords, Compute Engine, fixed number of instances, cloud storage, popular songs, improve the performance of the application.
The correct answer is option D, 1. Create a managed instance group with Compute Engine instances. 2. Create a global load balancer and configure it with 2 backends, Managed Instance Group Cloud Storage Bucket 3. Enable Cloud CDN on the bucket backend.
Why is this correct? D. Using a global load balancer with Cloud CDN on the cloud storage bucket backend caches popular music files at edge locations, reducing latency and offloading traffic from cloud storage and Compute Engine instances. A managed instance group provides scalability and high availability for the application. Why are the others incorrect? A. Mounting cloud storage with Xfuse creates file system translation overhead and routes content delivery through Compute Engine instances, failing to provide edge caching for popular content and increasing instance load. B. Using Cloud File Store introduces additional infrastructure management and routes stream traffic through backend instances rather than leveraging edge caching for static media files stored in cloud storage. C. Storing audio files as blobs in Cloud SQL is costly, unscalable, adds database load, and creates complex application logic instead of using an edge caching network designed for static media delivery.
The operations team in your company wants to save Cloud VPN log events for 1 year. You need to configure the cloud infrastructure to save the logs. What should you do? The options are Option A. Set up a filter in cloud logging and a cloud storage bucket as an export target for the logs you want to save. Option B. Enable the Compute Engine API, and then enable logging on the firewall rules that match the traffic you want to save. Option C. set up a cloud logging dashboard titled Cloud VPN Logs, and then add a chart that queries for the VPN metrics over a 1-year time period. Option D, set up a filter in cloud logging and a topic in pub/sub to publish the logs.
To arrive at the correct answer, we focus on the keywords, Cloud VPN log events, 1 year, save the logs.
The correct answer is option A, set up a filter in cloud logging and a cloud storage bucket as an export target for the logs you want to save.
Why is this correct? A. Routing Cloud VPN logs to a cloud storage bucket via a cloud logging export sync enables cost-effective, long-term retention required for holding log events over a 1-year period. Why are the others incorrect? B. Enabling firewall rule logging records traffic allowed or denied by firewall rules, but it does not export or store Cloud VPN log events for long-term retention. C. Dashboards and charts in cloud logging are designed for visualization and metric monitoring, not for long-term storage or archiving of log events. D. Streaming logs to a pub/sub topic is useful for real-time processing and integration, but pub/sub is a messaging service and does not offer long-term log storage.
You are working with a data warehousing team that performs data analysis. The team needs to process data from external partners, but the data contains personally identifiable information, PII. You need to process and store the data without storing any of the PII data. What should you do? The options are: Option A, create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, use the Cloud Data Loss Prevention, Cloud DLP, API to remove any PII data. Store the result in BigQuery. Option B, create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, store all non-PII data in BigQuery and store all PII data in a cloud storage bucket that has a retention policy set. Option C, ask the external partners to upload all data on cloud storage. Configure bucket lock for the bucket. Create a data flow pipeline to read the data from the bucket. As part of the pipeline, use the Cloud Data Loss Prevention, Cloud DLP, API to remove any PII data. Store the result in BigQuery. Option D, ask the external partners to import all data in your BigQuery dataset. Create a data flow pipeline to copy the data into a new table. As part of the data flow bucket, skip all data in columns that have PII data.
To arrive at the correct answer, we focus on the keywords, process data from external partners, personally identifiable information, PII, process and store the data without storing any of the PII data.
The correct answer is option A, create a data flow pipeline to retrieve the data from the external sources. As part of the pipeline, use the Cloud Data Loss Prevention, Cloud DLP, API to remove any PII data. Store the result in BigQuery.
Why is this correct? A. Using data flow with the Cloud Data Loss Prevention, Cloud DLP, API inspects and redacts PII data in flight during ingestion, ensuring no PII is ever stored in the target dataset. Why are the others incorrect? B. Storing PII data in a cloud storage bucket directly violates the mandatory requirement to not store any PII data. C. Uploading raw files to cloud storage stores PII before data flow processes it. Enabling bucket lock further prevents removing that PII, violating the requirement. D. Importing raw data directly into BigQuery causes PII to be stored initially. Skipping entire columns manually instead of using Cloud DLP to redact specific attributes is inadequate and error-prone.
You want to allow your operations team to store logs from all the production projects in your organization, without including logs from other projects. All of the production projects are contained in a folder. You want to ensure that all logs for existing and new production projects are captured automatically. What should you do? The options are: Option A, create an aggregated export on the production folder. Set the log sync to be a cloud storage bucket in an operations project. Option B, create an aggregated export on the organization resource. Set the log sync to be a cloud storage bucket in an operations project. Option C. Create log exports in the production projects. Set the log syncs to be a cloud storage bucket in an operations project. Option D. Create log exports in the production projects. Set the log syncs to be BigQuery datasets in the production projects, and grant IAM access to the operations team to run queries on the datasets.
To arrive at the correct answer, we focus on the keywords, store logs from all the production projects in your organization, without including logs from other projects, contained in a folder. Existing and new production projects are captured automatically.
Correct answer is option A. Create an aggregated export on the production folder. Set the log sync to be a cloud storage bucket in an operations project.
Why is this correct? A. Creating an aggregated sync at the folder level automatically exports logs for all existing and new projects in the production folder while excluding non-production projects outside the folder. Why are the others incorrect? B. An aggregated export at the organization resource captures logs from all projects across the entire organization, including non-production projects. C. Configuring log exports at the individual project level requires manual setup for newly created projects, failing the automatic capture requirement. D. Creating per-project exports fails to automatically capture logs from new projects, scatters logs across separate datasets, and increases administrative overhead.
Your company has an application that is running on multiple instances of Compute Engine. It generates 1 terabyte per day of logs. For compliance reasons, the logs need to be kept for at least 2 years. The logs need to be available for active query for 30 days. After that, they just need to be retained for audit purposes. You want to implement a storage solution that is compliant, minimizes costs, and follows Google recommended practices. What should you do? The options are: Option A, 1. Install a cloud logging agent on all instances. 2. Create a sync to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a ColdLine cloud storage bucket after 1 month. 4. Configure a retention policy at the bucket level using Bucket Lock. Option B, 1. Write a daily cron job, running on all instances, that uploads logs into a cloud storage bucket. 2. Create a sync to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a ColdLine cloud storage bucket after 1 month. Option C, 1. Install a cloud logging agent on all instances. 2. Create a sync to export logs into a partitioned BigQuery table. 3. Set a time_partitioning_expiration of 30 days. Option D, 1. Create a daily cron job, running on all instances, that uploads logs into a partitioned BigQuery table. 2. Set a time_partitioning_expiration of 30 days.
To arrive at the correct answer, we focus on the keywords: 1 terabyte per day of logs, kept for at least 2 years, available for active query for 30 days, minimizes costs, Google recommended practices.
The correct answer is option A, 1. Install a cloud logging agent on all instances. 2. Create a sync to export logs into a regional cloud storage bucket. 3. Create an object lifecycle rule to move files into a ColdLine cloud storage bucket after 1 month. 4. Configure a retention policy at the bucket level using Bucket Lock.
Why is this correct? A. Installing the cloud logging agent enables automated log collection. Exporting logs via a sync to cloud storage minimizes long-term storage costs. Object Lifecycle Management transitions data to ColdLine after 30 days for low-cost archiving, while Bucket Lock ensures compliance and immutability for the required 2-year retention period. Why are the others incorrect? B. Daily cron jobs are unmanaged and unreliable compared to the native cloud logging agent. Additionally, omitting a bucket retention policy with Bucket Lock fails to satisfy compliance requirements for mandatory 2-year immutable log retention. C. Setting time partitioning expiration to 30 days in BigQuery permanently deletes logs after 30 days, violating the 2-year compliance retention requirement. Storing large log volumes long-term in BigQuery is also significantly less cost-effective than cloud storage coldline. D. Custom cron jobs are unmanaged and unreliable compared to Cloud Logging Agent. Setting time partitioning expiration to 30 days deletes logs after 30 days, failing the 2-year retention rule, while BigQuery storage is cost-prohibitive for long-term archiving.
Your company has just recently activated Cloud Identity to manage users. The Google Cloud organization has been configured as well. The security team needs to secure projects that will be part of the organization. They want to prohibit IAM users outside the domain from gaining permissions from now on. What should they do? The options are: Option A, configure an organization policy to restrict identities by domain. Option B, configure an organization policy to block creation of service accounts. Option C, configure Cloud Scheduler to trigger a cloud function every hour that removes all users that don't belong to the Cloud Identity domain from all projects. Option D, create a technical user, e.g., email protected, and give it the project owner role at root organization level. Write a bash script that sent lists all the IAM rules of all projects within the organization. Sent deletes all users that do not belong to the company domain. Create a compute engine instance in a project within the organization and configure Cloud to be executed with technical user credentials. Configure a cron job that executes the bash script every hour.
To arrive at the correct answer, we focus on the keywords: Cloud Identity, Google Cloud Organization, prohibit IAM users outside the domain from gaining permissions.
The correct answer is option A, configure an organization policy to restrict identities by domain.
Why is this correct? A. Using an organization policy with the domain restricted sharing constraint, IAM.allowed policy member domains, natively prevents IAM policy updates that grant roles to identities outside allowed cloud identity domains, enforcing preventive control from now on. Why are the others incorrect? B. Restricting service account creation prevents users from creating service accounts within projects, but it does not block granting IAM permissions to external domain users or identities. C. Cloud Scheduler and Cloud Functions create a reactive cleanup process rather than a preventive restriction, leaving a potential 1-hour security vulnerability gap where external users hold unauthorized permissions. D. Executing a scheduled bash script on Compute Engine is a complex, reactive workaround that leaves security gaps between runs and requires unnecessary administrative credentials, whereas organization policies provide native, instant preventive enforcement.
Your company has an application running on Google Cloud that is collecting data from thousands of physical devices that are globally distributed. Data is published to pub/sub and streamed in real time into an SSD Cloud Bigtable cluster via a data flow pipeline. The operations team informs you that your Cloud Bigtable cluster has a hotspot, and queries are taking longer than expected. You need to resolve the problem and prevent it from happening in the future. What should you do? The options are: Option A, advise your clients to use HBase APIs instead of Node.js APIs. Option B, delete records older than 30 days. Option C, review your row key strategy and ensure that keys are evenly spread across the alphabet. Option D, double the number of nodes you currently have.
To arrive at the correct answer, we focus on the keywords: pub/sub, Cloud Bigtable cluster has a hotspot, queries are taking longer than expected, prevent it from happening in the future.
The correct answer is option C, review your row key strategy and ensure that keys are evenly spread across the alphabet.
Why is this correct? C. Cloud Bigtable performance depends heavily on row key design. Hotspotting occurs when reads/writes concentrate on a narrow key range. Ensuring row keys are evenly distributed across the alphabet spreads traffic uniformly across nodes, eliminating the hotspot and preventing future occurrences. Why are the others incorrect? A. Changing the client API from Node.js to HBase does not modify the underlying data distribution or table schema, failing to address the root cause of row key hotspotting. B. Deleting historical records decreases storage consumption but does not resolve uneven read/write distribution across active key ranges or prevent hotspotting. D. Adding more nodes increases total cluster capacity, but traffic targeted at a single hotspot region will still route to the node responsible for that key range.
Your company has a Google Cloud project that uses BigQuery for data warehousing. There are some tables that contain personally identifiable information, PII. Only the compliance team may access the PII. The other information in the tables must be available to the data science team. You want to minimize cost and the time it takes to assign appropriate access to the tables. What should you do? The options are: Option A, 1. From the dataset where you have the source data, create views of tables that you want to share, excluding PII. 2. Assign an appropriate project-level IAM role to the members of the data science team. 3. Assign access controls to the dataset that contains the view. Option B, 1. From the dataset where you have the source data, create materialized views of tables that you want to share, excluding PII. 2. Assign an appropriate project-level IAM role to the members of the data science team. 3. Assign access controls to the dataset that contains the view. And the remaining options are: Option C, 1. Create a dataset for the data science team. 2. Create views of tables that you want to share, excluding PII. 3. Assign an appropriate project-level IAM role to the members of the data science team. 4. Assign access controls to the dataset that contains the view. 5. Authorize the view to access the source dataset. Option D, 1. Create a dataset for the data science team. 2. Create materialized views of tables that you want to share, excluding PII. 3. Assign an appropriate project-level IAM role to the members of the data science team. 4. Assign access controls to the dataset that contains the view. 5. Authorize the view to access the source dataset.
To arrive at the correct answer, we focus on the keywords: BigQuery, personally identifiable information, PII. Only the compliance team may access the PII. Other information in the tables must be available to the data science team. Minimize cost and the time.
Review the options on screen. The correct answer is option C, 1. Create a dataset for the data science team. 2. Create views of tables that you want to share, excluding PII. 3. Assign an appropriate project-level IAM role to the members of the data science team. 4. Assign access controls to the dataset that contains the view. 5. Authorize the view to access the source dataset.
Why is this correct? C. Creating authorized views in a separate dataset allows the data science team to query non-PII data without direct access to the source dataset containing PII. Authorizing the view grants it access to the source data securely, fulfilling security requirements with minimal administrative overhead and no additional storage cost. Why are the others incorrect? A. Creating views in the source dataset requires granting the data science team access to that dataset, which exposes the underlying source tables containing PII. B. Creating views in the source dataset exposes sensitive PII tables to the data science team. Additionally, materialized views introduce unnecessary storage and maintenance costs. D. The materialized views incur unnecessary additional storage and processing costs compared to standard views, violating the requirement to minimize cost when standard authorized views meet all needs.
Your operations team currently stores 10 terabytes of data in an object storage service from a third-party provider. They want to move this data to a cloud storage bucket as quickly as possible, following Google recommended practices. They want to minimize the cost of this data migration. Which approach should they use? The options are: Option A, use the sudo-mv command to move the data. Option B, use the storage transfer service to move the data. Option C, download the data to a transfer appliance and ship it to Google. Option D, download the data to the on-premises data center and upload it to the cloud storage bucket.
To arrive at the correct answer, we focus on the keywords 10 terabytes of data, third-party provider, cloud storage bucket, Google recommended practices, minimize the cost.
The correct answer is option B, use the storage transfer service to move the data.
Why is this correct? B. Storage transfer service is Google's recommended tool to move data directly from third-party cloud object storage to cloud storage online, offering automated, high-speed transfer while minimizing data egress costs and operational complexity. Why are the others incorrect? A. Using SUDL-MV streams data through an intermediate local machine or compute instance, adding extra bandwidth, network hop latency, and management complexity compared to direct cloud-to-cloud transfer. C. Transfer appliance is designed for offline migration of on-premises data. Shipping hardware for 10 terabytes already hosted in third-party cloud storage is unnecessarily expensive, slow, and complex. D. Downloading 10 terabytes on-premises before uploading to cloud storage introduces redundant double-hop egress transfers, extreme network bottlenecks, and significantly higher bandwidth costs.
You have a Compute Engine managed instance group that adds and removes Compute Engine instances from the group in response to the load on your application. The instances have a shutdown script that removes Redis database entries associated with the instance. You see that many database entries have not been removed, and you suspect that the shutdown script is the problem. You need to ensure that the commands in the shutdown script are run reliably every time an instance is shut down. You create a cloud function to remove the database entries. What should you do next? The options are, Option A, modify the shutdown script to wait for 30 seconds before triggering the cloud function. Option B, do not use the cloud function. Modify the shutdown script to restart if it has not completed in 30 seconds. Option C, set up a cloud monitoring sync that triggers the cloud function after an instance removal log message arrives in cloud logging. Option D, modify the shutdown script to wait for 30 seconds and then publish a message to a pub/sub queue.
To arrive at the correct answer, we focus on the keywords Compute Engine Managed Instance Group, Shutdown Script. Many database entries have not been removed, run reliably every time an instance is shut down.
The correct answer is option C, set up a cloud monitoring sync that triggers the cloud function after an instance removal log message arrives in cloud logging.
Why is this correct? C. Cloud logging captures instance termination events automatically. Setting up a log sync to trigger the cloud function decouples cleanup from the VM's lifecycle, ensuring reliable execution even if the VM or shutdown script fails to execute within its timeout window. Why are the others incorrect? A. Relying on the shutdown script to trigger the cloud function is unreliable because if the script fails or times out during VM termination, the function will never be invoked. B. VM shutdown scripts operate within fixed GCP time limits and cannot restart themselves if they fail or time out, making script modification ineffective for reliable execution. D. Relying on the shutdown script to publish to pub/sub fails because it still depends on the unreliable shutdown script executing successfully before the VM terminates.
You are managing several projects on Google Cloud and need to interact on a daily basis with BigQuery, Bigtable, and Kubernetes Engine using the Cloud CL tool. You are traveling a lot and work on different workstations during the week. You want to avoid having to manage the Cloud CLI manually. What should you do? The options are, Option A, use Google Cloud Shell in the Google Cloud Console to interact with Google Cloud. Option B, create a Compute Engine instance and install Cloud on the instance. Connect to this instance via SSH to always use the same cloud installation when interacting with Google Cloud. Option C, install Cloud on all of your workstations. Run the command Cloud Components auto-update on each workstation. Option D, use a package manager to install Cloud on your workstations instead of installing it manually.
To arrive at the correct answer, we focus on the keywords, Cloud CL tool, different workstations, avoid having to manage the Cloud CLI manually.
The correct answer is option A, use Google Cloud Shell in the Google Cloud Console to interact with Google Cloud.
Why is this correct? A. Google Cloud Shell provides a browser-accessible terminal preloaded with the Cloud CLI and common tools, requiring zero local installation or manual maintenance across multiple workstations. Why are the others incorrect? B. Creating and maintaining a Compute Engine VM creates unnecessary management overhead and ongoing costs simply to access the Cloud CLI when Cloud Shell provides a managed alternative. C. Installing cloud on all workstations still requires manual setup and maintenance per device, failing to eliminate local environment management. D. Using a package manager still requires executing commands and managing cloud installations across each separate workstation manually.
Your company recently acquired a company that has infrastructure in Google Cloud. Each company has its own Google Cloud organization. Each company is using a shared virtual private cloud, VPC, to provide network connectivity for its applications. Some of the subnets used by both companies overlap. In order for both businesses to integrate, the applications need to have private network connectivity. These applications are not on overlapping subnets. You want to provide connectivity with minimal re-engineering. What should you do? The options are: Option A, set up VPC peering and peer each shared VPC together. Option B, migrate the projects from the acquired company into your company's Google Cloud organization. Relaunch the instances in your company's shared VPC. Option C, set up a Cloud VPN gateway in each shared VPC and peer Cloud VPNs. Option D, configure SSH port forwarding on each application to provide connectivity between applications in the different shared VPCs.
To arrive at the correct answer, we focus on the keywords, subnets used by both companies overlap, private network connectivity, applications are not on overlapping subnets, minimal re-engineering.
The correct answer is option C, set up a Cloud VPN gateway in each shared VPC and peer Cloud VPNs.
Why is this correct? C. Cloud VPN allows connecting VPC networks with overlapping IP ranges by establishing IPsec tunnels and routing traffic specifically between non-overlapping subnets, providing private connectivity with minimal re-engineering. Why are the others incorrect? A. VPC network peering will completely fail to establish if any IP subnets overlap between the peered VPCs, regardless of whether the communicating subnets themselves overlap. B. Migrating projects across organizations and relaunching compute instances requires extensive re-architecting, configuration effort, and downtime, violating the requirement for minimal re-engineering. D. SSH port forwarding is a complex, unscalable administrative workaround that operates at the individual application level rather than providing true private network layer connectivity.
You are managing several internal applications that are deployed on Compute Engine. Business users inform you that an application has become very slow over the past few days. You want to find the underlying cause in order to solve the problem. What should you do first? The options are: Option A, inspect the logs and metrics from the instances in Cloud Logging and Cloud Monitoring. Option B, change the Compute Engine instances behind the application to a machine type with more CPU and memory. Option C, restore a backup of the application database from a time before the application became slow. Option D, deploy the applications on a managed instance group with auto-scaling enabled. Add a load balancer in front of the managed instance group, and have the users connect to the IP of the load balancer.
To arrive at the correct answer, we focus on the keywords, Compute Engine, application has become very slow, find the underlying cause, what should you do first?
The correct answer is option A, inspect the logs and metrics from the instances in Cloud Logging and Cloud Monitoring.
Why is this correct? A. Inspecting logs in cloud. Logging and metrics in cloud monitoring is the essential first step to diagnose performance issues, identify resource bottlenecks, and discover the root cause of application slowness before making architectural changes. Why are the others incorrect? B. Resizing instance machine types without investigating logs and metrics assumes resource saturation without empirical evidence and may fail to solve the actual underlying issue. C. Restoring a database backup causes unnecessary data loss and downtime without verifying whether the database is responsible for the slowness. D. Redesigning infrastructure with managed instance groups and load balancers is a scalability architecture update rather than an initial diagnostic action to find the cause.